Pierce, this is Dr. Jones checking in. This is ANP2, lecture test 5, video. We're on 6 because we did 5 last time, so that sounds about right. Let me write it down before I forget. Video 6, and let's see, last video we did pages 10 and 11, but we didn't quite finish 11. So we're starting towards the bottom of page 11 today, which for me looks like this, just under the chart, if I can get it in the screen. 26.3, the nephron forms urine by filtration, reabsorption, and secretion. So this is what we're looking at. Primary function of urine production is to regulate the volume and composition of blood. Kidneys primarily act as a blood filter. The liver also filters blood and makes a lot of the blood proteins. The spleen also filters blood, filters out platelets and such, but lots of blood filters. But now we're talking about the kidney. So, process involves the excretion of metabolic wastes. Digestive wastes stay in the tube and leave via the tube. So digestive wastes get pooped out. But we're talking about metabolic wastes, waste from the cell's metabolic processes. And there's nowhere for these wastes to go. They go into the bloodstream, and the urine is how we get rid of them. So the kidneys filter these metabolic wastes out of the bloodstream, sometimes actively put them into the urine so that you can pee it out. 3 important metabolic wastes. We've got urea from amino acids, creatinine from muscles, and uric acid from RNA. Since these are cellular waste products dissolved in the bloodstream, urine is the only way to eliminate them. The kidneys also reabsorb and retain some sugars and amino acids. Page 12. 3 distinct processes that happen in, there we go. 3 distinct processes that happen in the renal tubules. In the nephrons. Filtration, because that's not in the tubule, that's at the renal corpuscle here. Filtration, the blood pressure forces the water and solutes into the capsular space, and it's now called filtrate. And we're filtering here based on size. So if you had a colander with kind of big holes in it, and you made a pasta with peas in it, and then you rinsed the pasta off, and the peas fell through, that's what happens in the filtrate. The filtrate is the pasta water and the peas. Peas here being like glucose and nutrients that we want to keep. So my suggestion is to buy a better colander with smaller holes so that your peas won't fall out in the sink. Okay, I'm still sleepy. And then the reabsorption happens. And that's where you remove water and solutes from the filtrate and return it to the peritubular fluid and then the peritubular capillaries. And secretion is when you transport waste into the tubular fluid. So once you've filtered stuff out into the filtrate, it's kind of considered outside the body. So when the nutrients are pulled back into the cell, they're being reabsorbed back into the body so that they aren't peed out. Whereas secretion is where you take other wastes that are in the bloodstream through these cells and secrete them into the tubular fluid so that they will be peed out. So reabsorption is recatching all of the peas before they fall in the sink and keeping them in your food because peas are good stuff. Secretion is when you take other stuff that's not good, like, pick something that's not good, urea, and put it into the tubular fluid. Now, because of its size, urea is not filtered it's not in the filtrate, because this just filters by size here. The filtration membrane is just a literal, like, what fits through filter. and the urea doesn't. And so the urea, the creatinine, it's so hard to say, and the uric acid are all actively secreted into the tubular fluid. So reabsorption is how you keep the good stuff. Secretion is how you get rid of the bad stuff. And the filtration is just what squeezes through the hole is what gets filtered. That's it. Okay, it's not pulling up, so I do the arrow. Oh, coffee. Coffee sounds fabulous. So glomerular filtration is when you make filtrate by squeezing liquid into the capsular space. So our book compares this to a coffee maker. So the coffee maker will be the renal corpuscle. Gravity will be the hydrostatic pressure. This is the force that's moving fluid across the membrane. Hot water will be the plasma in our kidneys here. The filter is, of course, the filtration membrane. The coffee grounds are the large solutes and proteins that don't go through the filter. And then the nectar of the gods is analogous to the filtrate, what gets squeezed into this capsular space. That's not popping up, so use the arrow. 3 layers of the filtration membrane and what they filter. The fenestrated endothelium catches the red blood cells. So here's the pore, and the red blood cells get caught here. They can't go through. Then we have the basement membrane, and it catches the medium plasma proteins. The medium plasma proteins can't fit through. They get caught. They stay in the bloodstream. And then these are the pedicels, which they have since renamed as foot processes, which is English for pedicels. And these are part of these podocytes. So this inner lining, this glomerular epithelium, this visceral epithelium is made of these cells called podocytes. And they have these little fingers called pedicels or foot processes, which, I don't know, they look like fingers and not feet to me, but whatever. And then there's a little slit between them, a little space. See the little red zigzag? The red zigzag's the filtration slit. That's the space between the pedicels / foot processes of the podocytes. I know. I'm sorry. It's what it is. And what the filtration slit is the 3rd smallest hole, and only the small plasma proteins like albumin. Well, it catches the small plasma proteins, but some of the albumins still fit through. Okay. So this hole, sometimes in the lab test, they will point to the nucleus of the podocyte, and what's that cell? And people think that the nucleus on that lab model is the cell, but that's the nucleus. The cell is this whole purple spiel squiggling out everywhere. And then the little sticky outy processes, the little pedicels, finger, foot processes, are the pedicels which are part of the podocyte. Clear as mud? Yeah. And so here's your filtration membrane, the pores of the fenestrated epithelium, the basement membrane, and the filtration slits, which are, of course, the gaps. It'd be like okay, my hands are the podocytes, and my fingers are the pedicels / foot processes. And they fit together like zipper teeth, but with spaces. So the spaces, hello, are the filtration slits. Okay. And the filtrate contains dissolved ions and small organic molecules in roughly the same concentrations as plasma. The hydrostatic pressure is the fluid pressure, and the colloid osmotic pressure is the pressure from the materials, proteins, in solution. So a colloid is a solution with large organic molecules in suspension. And that's all I have to say about that. This the next bit is its own thing, and we'll start that fresh. So we did 11 and 12. This has been ANP 2, lecture test 5, video 6. We finished off 11 and covered page 12. We will start at the top of page 13, dun dun dun, with the next video. Thank you, as always, for tuning in. The education must go on. Dr. J out.